Hello, good morning, students. Uh, we have already started these chapters from the chemistry sections, that is atoms and molecules in the previous videos, and this is our next second videos on these chapters. Okay, so in the previous video we have discussed about the discoveries of the atoms and different theories. Okay, so different theories discussed, different law of chemical combination we have discussed, and delta and atomic theory we have discussed, and we also have discussed about the atoms in the last classes. But today we will be discussing about the molecules and ion solid. Today we will be discussing about the molecules and ion, and chemical formula of compound, molecular formula of compound, formula unit mass will be discussed in next top chapters. Okay, next video lectures. Okay, so I believe that you will understand. Okay, so I believe that you will understand, and I will try to make it more easier to make you understand. Okay, so let's get started. Today we will be discussing about the atomic mass. You see, a mass is the characteristics properties of any matters. Okay, the mass is what is the characteristic properties of a matters. Okay, if any matter is here, that means there should be a mass, or they should occupy the space. Okay, hence the atom also present the mass. Okay, atom which is present in the matter also consists of a mass. Okay, since the mass is present in the atom, that is why the matters, okay, have a space in it. Okay, that's the mass of an atom is known as an atomic mass. Okay, then now you see the atoms of any same elements of over given element like hydrogen atoms and hydrogen atoms. Okay, let's talk about two hydrogen atom. Two hydrogen atom will have a same shape also, they will have a same size also, and they will have a same chemical property, and they will have a same mass. Okay, but two different element like hydrogen you are taking in one hand, and oxygen you are taking in another hand. Okay, and you are trying to compare them. Okay, then you will find different mass. Okay, you will find a different mass. Okay, you will find a different mass, and their chemical property will be different. That means two hydrogen, two same elements, two same elements will have a same shape, same size, mass, and the chemical property. But atoms of different element will have different mass and their different chemical properties. That is what it says. Okay, so this is about this is all about the mass. Okay, let's discuss the determinations of atomic mass. You see, at the very beginning, it was very difficult to calculate. Okay, calculate the mass of any elements. Okay, so what happened? There come an idea that in order to calculate the mass of other any elements, we need to first go with the relative, that is relative atomic mass. Okay, so what is relative atomic mass? Okay, let's try to discuss with these examples. Let's try to discuss with this example. Let's say this is one atoms, which is of 2 units. Okay, two unit, or you can say, let's make it more clear by weight. Okay, weight by weight, let's say 2 kg. Okay, 2 unit or 2 kgs. And now you have a 3 balls. Okay, 3 or 4 balls you have. Let's say 10 ball you have. Okay, let's say 10 balls, 10 small ball you have, and you have a one big ball that is of 2 kg. And now we want to calculate the mass of this one. Okay, how many mass of this? But you didn't have any other units. You didn't have any other things to calculate it. So what will I do is that I will compare with this. I will compare with these two. Okay, I will keep on comparing with these two. So two element, maybe two balls. Okay, will try, or 3 balls. Okay, will try to be equal with this mass. Then another 3 balls also will become equal to this term. That means what? Total 6 balls is equal to total 3 balls is equal to 2 mass. That means 6 ball will be the mass of 4, right? So 4. Similarly we can keep on comparing the ball as much as it presents. Okay, so that is what we call a relative mass. That means what? A relative mass is comparing the mass of that particular atom with its reference atom that you got. Okay, that you know already. So that is what we call the relative atomic mass. Okay, so and then we give the unit of that a relative atomic mass as an atomic mass unit. Okay, so at the very beginning, the John Dalton, so that we have already discussed about the John Dalton, he suggested that hydrogen will be taken as a standard reference to calculate any atomic mass. Okay, at the very beginning, what happened? Hydrogen atom was taken. okay, as a reference. From the hydrogen atom, with the respect of hydrogen atoms, we calculate the mass of oxygen, mass of carbon, mass of nitrogen. Any element is there, we calculate with the reference of the hydrogens. Okay, but later on it was ruled out. Okay, later on it was ruled out, and then there come in another idea that if we want to calculate the mass of any element, then we should take that 1 by 16. Okay, 1/16 means what? 1 by 16 of the mass of the oxygen. Okay, 1 by 16 mass of the oxygen was taken as a standard later on. Okay, but why this, you see, why this oxygen was taken? Why this oxygen was taken? Because why they have ruled out the hydrogen? Why they have considered that oxygen 1 by 16 of oxygen should be taken? Okay, because this oxygens, okay, this oxygen, what happened? This oxygen will combine with any other elements like nitrogen. When they combine with nitrogen, they form a nitrogen dioxide. Okay, when they combine with carbon, they form a carbon dioxide, carbon monoxide. And when they combine with calcium, they form a calcium oxide, magnesium oxide, sodium oxide. Okay, so in this way, most of the oxygen will react with large numbers. Okay, this oxygen element react with large numbers and form a compound. That is why it is considered to be that is why it was taken. Okay, that is why it was taken as a standard. And the second point is what? This atomic, whenever we calculate the mass of any other element, the unknown mass of any element, then we always get, okay, the whole number with respect to the oxygen. Whenever we try to calculate the mass of carbon, okay, then with respect to the oxygen, then we will get the the mass of the carbon in a whole number. That means whole number, that means 0, 1, 2, 3, not in a decimal point, not in the fractions, or not in the irrational numbers. Okay, that is why these are the 2 points that they consider that the oxygen should be taken. Okay, but later on in 1961, okay, that IUPAC, what is the IUPAC? IUPAC is the International Union of Pures and Applied Chemistry. Okay, what is the IUPAC? IUPAC is it is a big organizations of the chemistries. Okay, where everything, whatever you calculate, whatever you try to find any values or anything that based on chemistry, okay, first of all we have to go and check with the IUPAC whether it is valid or not. Once the IUPAC is approved, that means whatever the research that you have done on the basis of chemistry get approved. Okay, so this IUPAC is a head, okay, is a parental bodies of the chemistry departments. Okay, these are parental bodies of the chemistry department. They have adopted that 1 by 12 mass of the carbon 12 isotopes should be taken as a standard unit. Okay, that means later on it was also ruled out. The mass of this oxygen was also ruled out, and then this IUPAC have given idea that 1 by 12 mass of the carbon 12 isotopes should be taken as standard unit to calculate any relative mass. And then they have given that any mass, okay, mass of any elements will be represent, the SI unit of any mass of atomic mass should be represented by a unified atomic mass with the letter by denoting the letter U. Okay, thus the atomic mass is equal to what? 1 by 12 into mass of the carbon 12. Okay, or 1 U is equal to what? 1 by 12 into carbon mass of the carbon 12. Okay, so this is how we calculate. Now you see what is the relative atomic mass as part is. Relative atomic mass of an atoms of an element is defined as the average mass of atom as compared to 1 by 12 mass of the carbon 12. Okay, so this is what okay. So later on, okay, this is what you can see. The mass of the hydrogen is the mass of the lithium, the mass of the lithium, beryllium, boron, carbon, nitrogens, okay, oxygens, fluorine 19, neon. You see, this is the mass, this is the column of the mass, this is the columns of the mass. Okay, so this is a different mass of the different element, that is from the atomic number 1 to 20. The atomic number we will discuss in the next chapter only. Okay, so this is the mass. Okay, so we have already discussed about the atomic mass. Now we will be discussing about the molecules. Okay, you see, atoms being a very small particles. Okay, being a very smallest particles. Okay, so they cannot exist alone. That means they cannot live alone. Okay, so these atoms will try to combine with another atoms. These atoms will combine with another atom to form some molecules. Okay, to form some molecules. So let's say these hydrogen atoms, okay, this hydrogen atom will not live alone. Okay, they will not exist alone. So in order to combine, in order to live, in order to exist, in order to live, that means this hydrogen may combine with either with the hydrogens, or this hydrogen may either combine with another element, that is oxygens. Okay, so whenever they combine, okay, whenever they combine, then they will form a hydrogens or hydrogen gas. Okay, or this may come, they will form a, what is it, waters. Okay, so in this way, okay, in this way, if one or two atoms, okay, or if two or more atoms combine to forms and compound, that compound is called as a molecules, and these molecules are what, are stables. Okay, these molecules become stable, means they can live alone. Okay, so molecules are two, or you see atoms are very small in size, and it cannot be further divided into cannot be further divided. So yes, although atoms are the smallest particle of the substance, but atom of the most elements are unstable, that is not stable at all and cannot live alone. Okay, therefore two or more atoms of a same or a different elements combined to form a stable entities, that is called molecules. Okay, so and molecules can be defined as the smallest particles of element or compound that is capable of independently existence is called as the property. So this is your definitions. Okay, molecule is what is a combinations. It is a combinations of two or smallest particles of elements that have a capable to live. Okay, or exist, capable of existence. Okay, and their chemical properties are same. That is what we call as the the properties of the all the properties of the substances is called as a molecule. Okay, next you see the different types of molecules are what. The first one is the molecules of element, and then we have the molecules of compound. So first of all, we'll try to understand about the molecules of element. What is molecules of element? And molecules of elements are composed by the same types of atom. That means what, if one atoms, these hydrogen atoms, if hydrogen atom will combine with hydrogen atoms only, okay, hydrogen atom will combine with hydrogen atom only, so such types of compound is known as a such types of molecule is known as a molecules of element. And oxygen will combine with another oxygen only, carbon will combine with another carbon. In this way, same element, molecules of same element or same types of atom will combine with each other together, then only we call as the molecules of element. You see, atomicity is what is it? The numbers of atoms. Okay, the numbers of atoms. Okay, that are combining to form say molecules is called as atomicity. How many numbers of atoms are being used to form a molecules? So that the numbers of that atom is called as a atomicity. You see, here you see two hydrogens are combining. That means the atomicity of this is what? 2. Okay, so in this way, atomicity is based on numbers of atoms. Atomicities are being subdivided further. Okay, the first one is what? Monoatomic. Second is what? Diatomic. So diatomic and triatomic. Monoatomic means what? They are composed of only one atom, and mostly these monoatomics are noble gas. That is why we call as a monoatomic gases. What is it? Like neon, argon, helium, neons. Okay, so these are some elements that have only one atoms. But if the atoms have if the molecules have two atoms, then we consider them to be the diatomic, like your hydrogen gas, as is given in the examples out here. Okay, as is given in the examples out here. So such types of elements are called as the diatomic. Why? Because two hydrogen atoms are combining to form a hydrogen gas. The triatomic, those elements, okay, those elements which consist of 3 atoms are called as the triatomic, and these triatomics are totally unstable again. Okay. Similarly, we have a tetraatomic. What is it? If the element has a 4 atom, then means it's called as a tetraatomic. Polyatomic was polyatomic means what? Those elements which have more than 2 atom bonds is called as a polyatomic. You see, this is a polyatomic, monoatomic. Okay, this is a monoatomic. Argon, only one argon is here. Helium, only one helium is here. But this is a diatomic, this is diatomic, this is a diatomic, this is a diatomic, this is a tetra. Why? Because 4 phosphorus atoms are combining together. Similarly, this is a sulfur, 8 sulfur, so that's why it's called as a polyatomic. Okay, so Next, molecules of the compound. Molecules of the compound, one is that these hydrogens, okay, this hydrogen is several, not combine this hydrogen, but this hydrogen will further combine with another element, that is oxygen also. Then hydrogen can combine with any other element also. So such types of compound is, such types of molecule is known as a compound. Okay, molecules, atoms of the different element joined together. Atoms of the different element joined together in a definite proportion to form a molecules of compound is called as a molecules of compound. You see, so here you can see the two pictures out there. You see two hydrogen, two oxygen, two nitrogen, two chlorines are combining, so this is called as the element. And this is what two different atoms are combining, two or three different atoms are combining each other to form a compound, and to form a compounds. Okay, so this is all about the molecules of element, molecules of compounds. Okay, molecules of elements. Okay, so next we have ion. You see, a compounds like element like metals and non-metal, they always carry the charge. Okay, that charge is what we call as a positive ion. Okay, that charge is what we call as a ion. In your like physics also, we have like electric, you have electric wires. Okay, in there so you have a positive wires, negative wires. Similarly, in chemistry also we have a charge, and that charge is what we call as an ion. That charge is what we call as ion. That is what one is positive charge and another is negative charge. Okay, and that charge, we don't write this charge in the chemistry. Instead, we call them as a ion. Okay, we call this one as a ion. Okay, so here you see the positive charge. This positive charge is called as a cation. You see, cation is a cation. Okay, C-A-T-I-O-N. This T is present, yes, no, and this T is exactly like a plus sign or not, plus sign, right? So that is why it is called as a cation. Is known as a positive charge. We can easily remember, we can easily memorize in this way. And then when this, and then is what, that is negative charge, positive and negative charge, that is what we call anion and cation. Okay, so ion is what, it is a charge, okay, which is carried by the molecule compounds. Okay, and then if there is a positive charge, we call this as a cation. Negative charge, that is called anion. Okay, a group of atom carrying a charge is known as a polyatomic ion. Not I wrote only polyatomic, but it is called as a polyatomic ion. A group of atom carrying a charge is called as a polyatomic. You see, there is a group of atom. Here you have four oxygen and one, okay, phosphorus. That means total five atoms are there. It is a group, right? It is a group. That means they have, again, they are carrying a negative charge, that is anion. Here you see 1 and 5, that means they are carrying again positive charge, that is what we call as. So we have learned about the positives and negative charge, that is cation and anion, in terms of chemistry. Okay, so this will be the end of this topic for this in this videos. In this videos we have learned about the atomic mass, relative atomic mass, and molecules of elements, molecules of compound, and charges. Okay, so I want you to look back the videos again and go through the textbooks. That's all for today. Thank you. Bye bye.